Okay, I've been asked to go over this question. This says, suppose that 65% of the families in a town own computers. If 8 families are surveyed at random, what is the probability that at least 4 own computers? So in this case, the probability of success is 65%, so 0.65. And the probability of failure that they don't have a computer is 35%, or 0.35. So there's our success and failure. Now, this is a nasty question because it says at least 4, and doing this indirectly is not even going to save us a whole lot of time. When it says at least 4 out of the 8 random samples, so we got 8 that we're doing, so at least 4 means that we have to calculate that they have 4, or that they have 5, or 6, or 7, or 8, and then add them all together. If we were going to do this indirectly, we would have to subtract off the ones that we don't want, which is that they have no computers, 1 computer, 2 computers, 3 computers. So indirectly might be 1 fewer calculation than directly. I'm going to do it directly. Probability of at least 4 is equal to the probability that x equals 4 plus the probability that x equals 5 plus the probability that x equals 6 plus the probability that x equals 7 plus the probability that x equals 8. So we've got 5 calculations. We would have had to have calculated 4 times if we were going the indirect method. So 1 fewer calculations indirectly, but no big deal. Okay, so each one of these are binomial. So I've got 8 families. 4 of them are going to have a computer, which means that I have to use 0.65 to the exponent 4, because that's the probability they have a computer, and 4 of them did, and 0.35 to the exponent 4. And we're going to keep going like that. 8 choose 5, 0.65 to the 5th, 0.35 cubed, plus 8 choose 6, 0.65 to the 6th, 0.35 to the 2. Remember, all of these have to, excuse me, all of these have to add to 8 because there's 8 choices. So we get 2 more. Plus 8 choose 7, 0.65 to the 7, 0.35 squared. Oops, sorry, to the 1. Doop. To the 1. And then 8 choose 8, 0.658 times 0.351. Now, if you multiply all of these out, you're going to get 0.1875 for the first one, 0.2786 for the second one, 0.2587, 0.1373, and 0.0319. Now remember, when you're doing this, you might want to put stuff in brackets. The more, if you can't go wrong with putting a set of brackets around each term, but definitely try to punch this out and make sure you get the same answer as I do, which is 0.894 or 89.4%. So that means there's an 89.4% chance that we're going to find at least 4 computers in a family household. Now, part B is actually significantly easier than part A was. What is the expected number of families with computers? Well, if the expected number of families is always NP, if we've got 8 things and 65% of them are expected to be a success, we just do 8 times 0.65, and our answer is 5.2. So we would generally think that 5.2 people, or 5.2 families, that out of a sample of 8 would have a computer. Hope that helps.